Be real.
Okay. I was just seeing if Will was like close. Here's the problem.
He just walks out.
Okay. So vertical asymptotes, and let's just start with vertical asymptotes. So vertical asymptotes are when the bottom equals 0, and what else? The factors don't cancel, or what if there were factors? Like how else could you do it? The bottom is 0, and so if the bottom is 0 and the top is 0, what is that? A whole or a not jump. Removable discontinuity. So if the bottom is 0 and the top is 0, you have removable discontinuity. So vertical asymptote is when the bottom is 0 and the top is anything but 0. Okay? So if I look at number 1 here, I'm going to set that bottom equals 0. So x squared plus x minus 12. So that equals 0. I can factor that. X plus 4. X minus 3. And that would give me x equals negative 4 and x equals 3. So the two things you can do from here would be plug these back into the top. And if you get 0 on the top also, what is it? A whole or removable discontinuity. If you don't get 0, it's vertical asymptote. Or I know some people are factoring, like what Bowman just said. So if I factor the top, those factors would have canceled, which means when I plug in the top is 0, which means this is a removable discontinuity or a whole. But this one came from x minus 3, which didn't cancel, which means when I plug into the top, I won't get 0, which means it's a vertical asymptote. So when I go to do the limit, like a one-sided limit on these are weird. It's like I'm teaching math that's not math. You're almost just like guesstimating what's going on. So let's look at number 4 first, and then I'll come back to 2 and 3. 4 is probably an easier one to start with. So, first of all, are there any vertical asymptotes in number 4? This is the part where someone says something. Yes, where? Nice. We'll just walk in. He's kicking on. So if I set the bottom equal to 0, I'll get x equals 3, and if I plug 3 back into the top, do I get 0? I do not. So it is a vertical asymptote. So there's only 2 options for the limit at a vertical asymptote. If the graph is coming this way, it cannot cross this line. So it's either going to start like to get pressure to go up, kind of run next to it on the way up, or it's going to be pushed down. You only have 2 options. You could get that, or you could get that. So your limit at a vertical asymptote has to be positive infinity or negative infinity. It has to be one of those 2 things. You have vertical asymptote, as I get closer and closer to it, you're either getting shoved up forever and your y value is approaching infinity, or you're kind of getting shoved down because you can't go into it. So it's like a magnet. It's almost like repelling you down or up. You have to go one way or the other. So it's either positive or negative. So our job is to figure out which one. So here's the goofy part. You kind of just pick a number really close to 3 and plug in and kind of like guesstimate what happens. It's an interesting process. So I'm going to pick like 3.001. Let's even say just 3.01. So I will get 1 minus 3.01 over 3.01 minus 3. Before I'll come back to this, but like on the side here. If I have a very small number divided by a large number, so think about like 0.0001 divided by a million. What is that? Not equal, but it's really close. 0. So, like how many times would like a million go into? How many times would $1 million go into 1 cent? Not exactly 0, but it's pretty much 0. And if I have large over small, so like how many times would 1 cent go into $1 million? out, right? So when you're looking at positive infinity or negative infinity, it's going to be one of those. Because the limit has to be either positive or negative infinity. Basically, our job is to figure out the sign of it. Is it going to be positive or negative? So that's why we're plugging in like this number that's just to the right of 3. So 1 minus 3.01 would be negative 2.01. 3.01 minus 3 would be 0.01. So that is a large divided by a small, which is infinity. Because really, this number is getting closer and closer to 3, so this is really like negative 2.00000001 divided by 0.00. I'm not sure the zeros are going to be the same here, but that's the idea. So how many times does this incredibly tiny number go into 2? A lot, right? And does it go in a positive a lot or a negative a lot? Negative, and that's just because there's a negative divided by positive. So like this would be negative infinity. And it's weird because you're not like, it's not a calculator. I don't know, it just always feels funny to me to teach because I'm like, well, you kind of get close and then you look and you're like, that's pretty big, so infinity. But it's negative, so it's a weird process for you to teach. Let's go back to 2 and 3 up here. So I think it's easier for most people to plug into a factored form than into this like x squared plus 2x form. So I'm going to use the factored form. So I'll have x plus 4 over x minus 2, and then x plus 4 over x minus 3, and then this one gets even easier because those will go away. So you really just have this. And I know that 3 is a vertical asymptote. There's only 2 options for my limit. Either one up forever or one down forever. So some type of infinity. I just got to figure out which one. So that was, I drew over it, but that was 3 negative, right? That's 3 plus, so that has to be 3 minus. Okay. So plug in like 2.99. So 2.99 minus 2 over 2.99 minus 3. So 2. Someone just lasered the board.
No, I definitely saw that. It's something to red.
Right? It's what?
It's the red from your line. That was just on your face.
The red?
The line that you drew. The red line that you drew on the board when you walk across it, it like went on your face.
Oh yeah.
Oh really?
Yeah. And
But I
there's
saw
also
like a dot.
there's a like a red plasma that was also.
Okay.
But I saw it. I definitely saw it. But it definitely wasn't predicted.
Okay.
You're fine. No one's lasering you with that.
It'll be okay. We're on TV, she's trying to cover it.
Yeah, right.
My hands are clear. Something has
Shows up like whenever she feels like, says laser. Alright, so this is, 0.99. This, I don't care a ton about the number, but is that going to come out positive or negative? That's negative. So, this is what we're dealing with our estimate here, but really, as the number got closer and closer and closer to 3, you'd actually be dealing with something more like this. So how many times does this super tiny number go into 0.99999? Is a ton. Super official math, right? And then a positive infinity. Connor, will you guys with me? A positive divided by negative is a negative, so this one is negative. Does that make sense what I'm showing you? It does feel weird though, right? So let's look at the 3 from the right. I was actually hoping like the video guy had a better way to explain it because I never liked this, but we did the same thing. So this would be the same idea. I'm plugging in like 3.001, so like 3.001 minus 2 over 3.001 minus 3. So on the top, I get 1.001. Bottom, I get 0.001. So again, how many times does a really small number go into like a regular number? There's a bunch. So we say infinity, and that would be positive because they're both positive. So then with that in mind, those 2 in mind, I'm surprised they didn't put this on here. Don't say it, but think about what's the limit as x approaches 3, period. Not from the right, not from the left, just 3, period.
Yeah, just no. Thank you for bringing this up. You're welcome.
So, what's the limit as x approaches 3, period? Mr. Heika. So, if you had like this, it would be infinity because it matches. So from either side, I could say it's going up forever. But is that the scenario here? They don't match, right? And what do we do when the limits don't from each side are different? Is DNE. So this one would be DNE. Which they didn't ask, but I wish they would have, because I think it's pretty helpful. Did they?
Yeah.
Oh, okay.
didn't ask.
They like talked about it? Okay. So then, before I do 5, because I don't like going too fast. Questions on 1, 2, 3, or 4? Okay. So then 5, they kind of skip past they're like, we're not going to just like lead you into it and tell you, hey, check the left and check the right. They're just telling you X is approaching 1. It's your job to know that you have to check it from the left and the right. First of all, are there any discontinuities in this? So let's check that first. I set that equal to 0. Can I factor that? Sounds goofy for some people. So what multiplies to be positive 1 and adds up to be negative 2? Negative 1 and negative 1. So x equals 1 is a vertical asymptote. How do I know it's a vertical asymptote and not a hole? Can't cancel, or when I plug in 1, I don't get 0, right? So I know I have a vertical asymptote at x equals 1. So if I have a vertical asymptote, what am I only... Well, I guess there's 3 options for the limit as x approaches 1. What are the 3 options? It's vertical asymptote. There's 3 things that can happen. Infinity, negative infinity, and does not exist. From one side, there's only 2 options. Positive and negative infinity. From 2 sides, you can get positive infinity, negative infinity, or it doesn't exist. So we gotta check those. So, again, I think it's easier most of the time to use like the factored version, which is that. Or it might be even easier in this one to do like x minus 1 squared. So essentially, what's true about the bottom always? It'll be what? You're like, I'm wrong, so I'm not gonna repeat it. I don't know if you're wrong or not. What's true about the bottom always? Always positive, right? Because it's something squared. Squaring something doesn't have to be positive. I shouldn't say always, because where is it not positive? 0 minus 1 is negative 1 squared to the positive number. So we get that as 1. Because it's not anything at 1, right? It's a vertical asymptote. But everywhere else, it's positive. So I need to check the limit as x approaches 1 from the left, which would be like 0.999 minus 3 over 0.999 minus 1 squared. So 0.999 minus 3 is like negative 2.001. This one will be 0.001 squared, which actually makes more zeros. So it would be like that. So that's going to be infinity, right? Because our like superficial math says like regular number divided by an incredibly small number is infinity. So negative divided by a positive is negative. But when you look at it, weird.
No, we're good.
Okay.
You were saying infinity.
Okay.
Yeah, we're good.
And then I'm not done. I got to check both sides. They didn't really tell me I have to, but I'm just supposed to know that. So I'm going to check from the right. So I get like 1.001 minus 3 over 1.001 minus 1 squared. So on the top, now I have negative 1.9. I mean, essentially I have negative 2. I'm not that worried about, like, can you do, it doesn't really matter, right? Like, if I thought of this as negative 2, would it change the answer? It would not. And then the bottom is going to be a positive 0.001 squared, which is a positive really tiny. Like some people I've seen teach this as like, okay, that's a negative regular divided by a positive tiny. And then you're just supposed to go, okay, that's negative. Yeah, right? It's like worse than what we're doing. I hate what we're doing already. That makes it like, I hate it even more. So this is a situation where we have a vertical asymptote at 3 and it's going down from both sides. So I've got negative infinity over there, I've got negative infinity over there. So what's the overall limit? It's negative infinity. How's that? Seem alright? Questions? Okay. The very last one on there, like the practice AP one, is ridiculous. Like I wouldn't. You're not responsible for it. I'm never gonna ask you that. If you want to like look through it, I can talk you through what they're doing. But
Number 7.
So it was 7 and 8, yeah.
7 and 8.
oh yeah, you can skip those two.
Oh, really?
Yeah, that's fine. But again, like look at the answers, and I can talk you through if you want. But I'm not gonna make yours. So you can skip 7, 8, and 18. Yeah. So I can like start you on 17. I don't want to.
Well, no.
Don't start. It's similar to like the stuff we've done before. Just cosine like flipped over.
Yeah.
Yeah.
Oh, so yeah.
Which is right.
They both roads that just big like this.
Yeah, you can like wave at the person, so you can't get crowned.
Yes, but then why would it be, so if it's negative infinity, at least if you get to infinity, but you know.
I hate to look towards the 3 and
Or they just get so close that the roads.
which ones are correct and ones
That's more the answer.
We're like,
We're like, we're walking
so,
this way.
there's such a small
closer and
gap, you
closer.
could just go.
We're just like
it's like,
Just such a minuscule gap. You just-
right. So the limit seems that that's what it's heading towards. Right? That's the interaction. So we'd be like infinite flows.
Just a little monkeys with fashion. Just
And that happened. So it's like someone said describe a limit. Like I used to think you guys people write. So I said like write see what a limit means. And they said it's like if you're trying to leave the classroom, you walk halfway there, and you walk halfway there, and you walk halfway there, and then you take that, and you walk halfway there. You say, "Oh, shit." You'll never get there.
That's a bummer. So I see what I'm saying.
That's like mind blowing.
It's a purgatory.
That's
You walk halfway there, you get over there.
So he tried the girls' soccer team. He gets older.
Nice.
Who's this one?
What's this limit?
He's the girls' soccer manager.
Oh really?
Really?
He's like the stick.
That's cool.
So he gets paid. He gets all of the like all the T-shirts and the shoes
All
and
the swag.
all the swag, and he gets like all of the benefits of being an athlete. Like he gets an athletic.
He's like study table and food and all that stuff.
Probably. And he gets to travel with the team. And he doesn't.
And I mean,
He never has to practice or play games. He is there.
It's nice. It's like the only way you get girls to talk to them. So we're just moving forward tomorrow, right? 1.15 tomorrow. Finish this up. You want to do the notes for 1.5? 1.5. Man, I got these days right, don't I? Hey, is that 1.14 then? So yeah, we're almost done. So Wednesday, 1.4. Yeah, so it would either be, I'll have to look and see like what kind of review material I have and how long I want to spend on review. But your test will either be Tuesday or Wednesday.
No.
Why are you saying no?
Regionals. Next Thursday.
Oh, I thought you were saying no to that.
No, you were saying Thursday.
It won't be Thursday. You don't need that long to review.
What do you guys like?
Tuesday
It won't be Monday because I want to give you a
we're gonna win our regional.
Everyone not.
Yeah, we are. We're gonna get first place. We're
go swimming?
Yeah.
I saw them afterwards though. They were all coming up to her land.
Yeah. She swims from Trenton, right?
Yeah.
That's what I thought, but someone kept telling me it was Trenton today.
No, it's definitely she's trying to.
Yeah, they played. So
Because she's the only good person on Trenton.
She's so
we did get
good.
a full record yesterday.
We did.
Yeah. Oh, what the?
In our 400 for everything.
Yeah.
And Mary was 110.
It was so weird.
She really? Yeah.
Because
She went
like
111.
three of us went 59, 58, 59.
We went like it was not our best.
Yeah, and then Annabelle went at 54 because she's Annabelle. But we were like, what? I was so confused. Oh, Annabelle's so good. Yeah,
Yeah.
she puts everything into all the races.
And she doesn't even swim full year round. Or like, and she did swim a lot when she was younger. She's just really
Well,
good.
she does swim Florida Road now.
She does now. She did.
Yeah.
She didn't like
For a really long
2
time.
years ago. She didn't.
Yeah. She's so nice.
She almost seems like clueless though. All the time.
Really?
She's like, that they put the two most clueless people on our team in one lane. And it's oh my god, they never know what's Lila, the girl that was bragging about how she only had 3 events, but she really almost missed her first event. And then they put Annabelle there, and Annabelle's just always like, what? She's smart.
Yeah, yeah,
She's like an airhead. Like she doesn't. She's like,
Keep it quiet, please. Don't want to distract people. Go on quiet.
You're so loud.
maybe.
Every take one of the pages on my test.
What are we talking about?
Oh,
I'm just gonna make a quote from every single class. Please don't.
Do you know what's annoying about him? After he finished early in the top.
I know.
But then he missed the paint. Like that's how he's talking while everyone.
What do you want?
He told me this test really early. Then
No, you called him out. You said it. But you called him. But still, you didn't. I was like, oh, there's a lot of people in your like stats class that I would not think. No, not Gavin. There's other people because
Let's
they were
keep it quiet, please.
yeah.
And we're not gonna like talk about other people that aren't here.
No. They were complaining about it. They're like, I cannot believe you're taking AP class. No.
So they could have just taken shots.
They're like, I'm just gonna tell.
Text. So today we had this
I
big
told him
group
to
as a
drop it.
substitute.
he never said no once.
Walked around. And then he just left.
Most of you do it, but not all. I strong recommend checking it. Because, last year you get feedback on things, or whether it's right or wrong. Better it is for your brain. But anyway. Can't make you. We're gonna make you, but it's super.
I like to check them at the end because then I don't want to at my computer like, oh, I don't know this one. Just look at the answers.
That's like working.
Yeah, that's like.
It's like I think you feel guilty because math teachers like your whole life have made us see like this or something secret. But that's not really how you learn. It's only like that some people cheat. But if you cheat, you'll do this, or